function notation is another way of giving a name to a function. Right now, what's the way we know how to name functions? Well, we say y equals 2x plus 1. This is our output variable, right? And this is our input. So based on an input value, let's say the input was 1, x is 1. What would my output be if the input is 1? So my input is 1. What do I get? 3. Right. So y would be 3. So input 1 gives us output 3. Is this a mystery? Is this anything new? No, right? We've been playing with this a little bit. So now we're going to name it, instead of calling this thing y, the output is y, we're going to call the output this thing, f in parentheses and x. And we pronounce this, we say f of x. F of x equals whatever. It means the same as y. Now I changed its name. Is anything different about these functions now that I changed its name from y to f of x? No, it's the same thing. In fact, it gives us a little bit of more information. Think of it as a function who has a name. His name is f. And his input is this variable, x. It could be Fred. You could have called it Fred of x. Okay. So, function f has an input of x. X is the input variable in the function. We don't have to use an f. We could call it g of x. And we could call it h of x. We could call it all different names. Usually one letter. We don't usually call it Fred of x, but I don't see why not. Who did? Fred of x? Okay, well, Andrew of x. Either we could. But we usually just use the one letter. Means the same thing. That's the good news. See how happy he is? Everything is the same. It still has a domain. It's going to be a set of inputs. It still has a range. Just going to be the set of outputs. We graph them the same way. You can make a table of values. You can use an intercept method. Everything's the same, but I have a new way of naming it. And why is that a good thing, this f of x notation? One thing that's nice is very often we do put different graphs on the same plane. So now I can name them. This one here is f, this one is g, this one is h. I can refer to them now because they have names. They're all not just y equals. We can easily know input values. This one has an input of x. This one has an input of x. Look at this one. It has an input of t. But they all go on, this horizontal axis. That's my input. This is because later on you can have more than one input. You can have 2 variables as input. This is going to happen eventually, not this year. Yeah. But this allows us to say, you have a function at this time it has 2 inputs. So it lets us kind of define what we're using a little bit better than just saying y equals. Find an output given an input. So how does this thing work? So to find an output given an input value, remember you have done this already. I should say that again. You have done this already. We're just giving it a different little bit of notation. Let's pretend that I have y equals 3x minus 15 instead of f of x equals 3x minus 15. Do these things mean the same thing? Yes. I just replace y with a name for the function. What if I wanted to know what is y if input x is 3? Can we answer this question up here? What is y if input x is 3? How would you do that? But how would you do it? 3 x. Andrew, how would I do this? Plug in the 3 where the x is. Exactly. 9 minus 15, right? And I get negative 6. Now this notation here says all that in just like these few little characters in it. This says find the output if the x is 3. Find the output if x is 3. So f of 3 says, let's rewrite f of x right above it. F of x is 3x minus 15. What did I replace? The x, right? Didn't I replace the x over here? Didn't I? It says f of x, now it says f of 3. Did that get replaced? Did you guys go, where are you guys?
I don't know.
I don't know, it's like everybody disappeared. Did I replace the x with a 3? Yes. So what do I do here? Replace the x with a 3. Right? The x is matched now, my 3 is matched. And then what do I get? Same thing we did before. This notation means f of 3 says replace x with 3. What do you think f of 10 means?
But what do you do with that?
Replace it with 10. So f of 10, if f of x is 3x minus 15, f of 10 is 3 times 10 minus 15. Wherever you see an x, you do that replacement. 30 minus 15, 15. Let's do a different one. What is f of 2? With the same definition of f of x. Somebody's having a little trouble, like, what? I don't know what you're doing. Raise your hand if you just want to be, just walk me through it. Or do I walk through it? No? Or you and me walk through it? All right, so f of 2, how am I going to handle that? What did I replace here? So what am I going to write? Shush. Go ahead, Tori. Right, but what's my x? 2. So I replace the x here, I'm going to replace the x here. So what does this mean, f of x? Or f of 3? Replace the x. Plug it in, basically. Plug in the x with whatever value we have there. It's not so bad. It's just new. It's a different way of looking at it. So how would I do f of negative 1? Looking for somebody having a little trouble seeing it. I just want to be walked through it. Okay, you want to try this one? No. So f of negative 1, what am I going to do? So that's negative 3 minus 15, which is? Negative 18, isn't it? Yeah, if you say so. Right? But what do? I replace the x over here. I'm going to replace the x over here. Yes?
Didn't you anything to like f negative 1 and just type
F of negative 1. That's all you got to do.
Is it always going to be f?
It could be g.
Equals 3.
No. Is it always y equals this? It could be anything.
It always be 3x minus 15.
For this example.
Oh, just
Yeah, right there. There's all kinds of functions, right? Yes.
I was gonna know like what. I was gonna know
Well, it tells you.
the.
We give you the function. It's like, how do you ever know what y is? I give it to you, right? They give it to you, say, here's the function, go off and do this. All right, now this is kind of the backwards, the opposite. Remember our table of values? Remember this thing, the x, the y? Usually we have an x, we go ahead and we find the y. Can I put the y's here? And say find the x? We do that with intercepts, right? You can put the 0 here. This means set the y equal to a value, find the x. So that's like finding an input given an output. So it's a little bit different. So thinking caps are on, yes? I'm looking. Tie them under your chin. Nice and tight, we're thinking. Because look at this guy. It says here's a function, f of x equals 2x minus 10. Find x such that, some of this, f of x equals 6. Now, did they replace the x here? Do I see a number here instead of x? No. Is this a plug-in? No. What am I replacing? See this f of x? See this f of x? They're the same. So what happens with these two things? They're the same. I'm replacing f of x now, not x. So let's see what I got here. F of x equals 2x minus 10, right? We agree? Yeah. I'm also telling you that f of x equals 6. Think of this if I said y equals 2x minus 10 and y equals 6. How would you go ahead and find x? Where would the 6 go? By the y. You would say this, right? Wouldn't you? Mm-hmm. So what's different? I'm just using f of x instead of y. So I'm going to replace the 6 goes here where the f of x was. These two things are equal, therefore these two things are equal. That's the transitive property of equality. You remember that thing? You remember that? If A equals B and B equals C, what's true? A equals C, that's what this is. Two things are equal to the same thing, therefore they are equal. Or just think of them as y and y. What do you mean what? Right? If f of x is this and f of x is that, doesn't that equal that? Substitution? Transitivity? Isha, are you listening? You look like you're not. Alright, so this is what I get. 2x minus 10 equals 6. Solve it for x. So I found the x that will make this be true. So f of 8 is the thing that gives me 6. When input is 8, my output is 6. Just plug the 8 in. When you get plug 8 in. 16 minus 10, isn't that 6? I worked backwards. You can think of a table. Maybe that helps. And I'm going to call y is f of x. So it's saying f of x is 6. So now go ahead and replace or find x. Let's try another one because we're all looking at me funny. All right? So find x such that f of x equals 0. So let's remind ourselves what f of x is. Well, it is 0. It's also 2x minus 10. So what do I do with this? What do? Do I plug 0 in?
Yeah, you put a 0.
Does it say x is 0 here?
No.
That's when you plug in. When you change this value, that's when you plug in. What am I saying is 0? This thing, right? Well, what is this thing? It's that. Think of it as, if you have to at first, if y equals 2x minus 10 and y equals 0, does it make sense that 2x minus 10 equals 0? Some people are able to see that, but they can't see the f of x for some reason. Can we see it with y? Can I see it with f of x? Yes. Sure. Right, can we do it this way? We can. Right, you can put the 0 there. Now how do you solve this equation? Add 10 to both sides. Divide both sides by 2. Well, I'm turning it around using the symmetric property of equality. X equals 5. So what's the x that works? 5. F of 5 equals 0. When you have an input of 5, you get an output of 0. That's what that means. Can I make an ordered pair out of this? If this is my input and this is my output, what ordered pair is represented here? What's my input? 5. What's my output? So you can actually see the ordered pairs from this notation as well. I can't tell if anybody is with me at all. Anybody? Question? Yes? No question? She's with me. Everybody else should have questions with that means. Other questions? Yeah. How do you know what to change? Like before we plugged it in, let's see what's over here. I'm not ready for that yet. I'm not ready for you yet. Let's do one of these. Let's see what that's doing. So let's say I've got, I'll pick a simple one. This is my function, f of x equals x plus 5, and that's the same as doing this. Right? X is my input. What's the output? This whole thing, right? Those are outputs. So if I say find f of 3, what did I replace, the input or the output? Well, what's this? I replaced where the x used to be, right? What's x? X is the input. So what did I replace? I replaced x, so I better replace x here. What? F of x is the output. Did I change f of x? I didn't change f of x, I just said x. I gave x a value. So let's put the matching value here wherever you see x. Now, as opposed to f of x equals 7. Am I setting an input? Did I change x? No. What am I saying? The output, this whole thing equals 7. Well, what is that whole thing? It's x plus 5, and it equals 7. This is what I want to solve now, x equals 2. So when x is 2, the output is 7. When the input is 2, the output is 7. So it's looking at what you're changing. This says the whole thing is going to be 7. Can we see the difference between this and this? What's the difference between those two things? Here I change the input, right? And here I'm changing the output. Okay? All right. One last question, then we're going to go to lunch. One last question.
Never mind. I'll
Should we? All right, we'll continue this when you guys. Okay. So zeros of a function. Now, a zero of a function is a very. Would you guys show me the board, please? The zeros of a function are a fancy way of saying, can you tell me where the x-intercepts of a graph are? The zero of a function is where the function equals 0, where f of x equals 0, where y equals 0. If y equals 0, right, I'm not going up and down. A zero of a function is an x-intercept. So if you have a graph, it's pretty easy. Where's the x-intercept? Right here. The zero of the function is that value 2. When x is 2, I have the zero of the function. So what if I have a wacky looking function? What if I have a function like this? I have many x-intercepts, so I also have many zeros. Where are the zeros of the function? Here, there, right there, right there, right there. Easy peasy. What's the y value for all those points?
up there, right there.
What's the y value for all those zeros? I could also say what? F of x equals 0. To find the zero of a function, they occur where f of x, the function itself, equals 0. So if you have a picture, it's quite easy. If you have a picture, it's easy. You'll look at the x-intercept. What are the x-intercepts of this graph? Negative 2 and 0 are the zeros of this function. They are where f of x equals 0. That's all that a zero of a function is. Where does the function equal 0? So we can algebraically find it as well. Now if I'm looking at this picture here, it's a little hard to read. That's f of x equals x minus 2. That's this line over here. Where is the x-intercept? Where is the 0? Over here when x equals 2. That's the 0 of the function, right? Is that where the x-intercept is? Get it up, Richard, over here. F of x equals 0. So what do I do? Here's my f of x. And I want to set it equal to 0 so I can find where my zeros of the function are. So remember what we do here? X minus, you take f of x, set it equal to 0, solve it for x. X equals 2. Isn't that what we got up here?
Yeah.
Yes. So how do you find the zero of the function? Set the function equal to 0, solve for x. Yes, sir.
How do you get x minus 2?
That is what this function is. You are given this function. Huh?
How do you get minus 2?
If they gave it to me. They said, here's your function, f of x minus 2. When you graph it, this is what you get. Either use the intercept method or use the table of values method. This is what you get. Now they say, what are the zeros of this function? You either look at it or set the function equal to 0 and solve. All right, now we're up to the futurize. Let's do a brief going over. There's 3 different things I'm asking you to do. One is, here's a function, f of x equals negative 7x. Find f of 7. How do I do that? No, I need more than one person. Come on. How do I find f of 7? What do you do? That's saying the x is becoming 7. So what did I change? I changed the x here. Now look at ones like this. It says f of x equals 6x minus 6. Find x such that f of x equals 24. So what do I do with this guy? What do I do with this one?
You take f of x take it out and put 24 in the order.
This is the whole function, this is f of x, 6x minus 6.
Yeah.
It equals 24, solve it for x. And then it says find the zero of this function. How do you find the zero of a function? Has anybody besides you been with me today? Am I the only one who knows any of the questions? How do you find it? The zero of f. How do I find the zero of this function? Think about it. Zero of a function is an x-intercept. The x-intercept, the value of y is always what? 0 or f of x equals 0. So you take your f of x, set it equal to 0, and solve. That's how we do it. Real briefly, these are challenge questions. Can I find f of 0 at a graph? If you remember that these are just y, where x equals 0, right? So what's y where x equals 0? Yeah, what coordinate is this? All right, so what's y? 0. All right, find f of x where it's negative 2. So here's x is negative 2. So what's f of negative 2? 4. So you're reading a graph, it's the same kind of thing. F of 2, what is that? Negative 2. What's f of negative 5? 0. Where's the zero of a function? What's f of 5? Negative 1. So you can read graphs of this. Find x when f of x is negative 2. Well, now I'm looking at this. Here's a negative 2. There's my y. What's x? 2. So you're reading the graph. Sometimes it's giving you inputs and asking you for outputs. Sometimes it's giving you outputs, asking for inputs. How about this? Translate these into xy pairs. Input negative 1 with output 1. What's the ordered pair? How are you getting these, Alice? Right? This is the x, and this is the y. Input, output. What's the ordered pair that goes with h of 2 equals 7? Input 2, output 7. What is the ordered pair? G of 1 equals negative 1. 1, negative 1. So is that much of a challenge, really? Once you get it, it's not so bad. All right, we're up to the next thing now. Turn her over. We are looking at this is a completely different topic. Well, not completely different, but different. Literal equations. Remember literal equations? We looked at these when we saw ax plus by equals c. Where the a, the b, and the c, they're not really variables. They're placeholders for constants that tell you the format of what it looks like, right? So the a, b, and the c are not the variables. The x and the y are the variables, and we can play with those. Well, what we're going to be doing is we're kind of looking at this idea of literal equations, expanding it a little bit. Let's look at formulas. I don't have a lot of 8th graders in here, but I do have some 8th graders, right? Look at my 8th graders. Have I taken science? Have you seen, like, I don't know, this one?
Yeah.
Now, didn't they give you some, like, density? Well, how does the triangle thing work? Well, how does that work? Yeah, Tori, how does the triangle thing work?
So you got a D at the top,
Yeah.
an M at the left, and a B at the right.
And what does that do for me?
It just tells you that, it tells you basically the formula is like, density divided by mass volume,
Okay.
and vice versa. And mass
So what's volume?
Volume?
Yeah.
Density divided by mass.
It's what?
Density divided by mass.
V equals what? M over D?
E divided by V equals M.
That's it? Well, because here's the thing. Here's what I want you to do. I want you to go, who's reading up the science? Mr. Relove. You're telling Mr. Relove, Mrs. Reeser said that I should throw this away. You're just going to say, what? Why are you listening to Mrs. Reeser? She's like, no. We learned how to do this in math. We're going to learn a way where if you can just remember the one formula, you don't need this. Because you can really derive the other formulas very easily. Who's good at solving equations? Oh, I hope every hand goes up. If you're good at solving equations, this is going to be a step. Because we are going to be looking at formulas and solving them all which ways. Like, for example, I'm going to start with F equals ma. Do we have that one yet in physics? Force equals mass equals acceleration?
Yeah.
Well, yeah, this is technique because you're doing the rockets.
the car.
Oh, the car.
Force
equals mass.
And I lost.
So this is easy. If you know the mass and you know the acceleration, I multiply it, I can get the force, right? with this too.
Triangle.
So here's what we're gonna do. We say, oh, I want this mass. Well, gee, if I had numbers here, if I had, well, this is silly masses, but let's say I had this. How could I find the mass? What would you do? Okay. Can I get the mass? Why don't I just do this? What happens if I divide by A? What is A divided by A, assuming A is not 0? 1. Do I get my M? So M equals F over A. I can just divide, right? What if I want acceleration? I've got F equals M over A. Now I know the force, I know the mass. Can I find the acceleration? Divide by what? M. Right? That's a big old one as long as M isn't 0. So A equals F over M. Do I need to stick a triangle? No. Is it easy? So what if I'm doing this? D, equals M over V. Density equals mass over volume, right? So what if I want to solve this for mass? What would I multiply by? Both sides, right? Because what's going to happen here? It's going to cancel out. So volume times density equals mass. I need a triangle. What if I want to solve for the volume? Can I just divide by D? Oops, I'm sorry. Yeah, divide by D. So volume equals mass over density. So do I have all the equations? Can I find them just by knowing one of them? Can I? Yes. You need the triangle. Now you tell Mr. Grego. Oh, yeah, except you couldn't remember. We weren't sure what volume was. I think you had it backwards. You had it backwards. You told me it was density over mass or something. Something was wrong. Thank you. Density. Thank you. I know, we're doing science. Is that okay, Ms. Orr? That's all right. All right, that's what I thought. I'm telling you to throw away that triangle.
Yeah. We were told to teach it, but most physics people don't use it. You just learn it by doing it. Like that's
But if we forget, we're using algebra to remember what the other formula is. We have to remember G equals M over V, but we can find it the other way. Yes, we do. All right. So we're basically learning how to solve for a variable. This is always confused. But she's like, don't tell them to throw out the triangle. Don't throw out the triangle. Use the properties of equality to solve linear equations. All right, if you can solve an equation with numbers, 3x plus 6 equals 12, how do you solve this equation?
you do the add and subtract.
Subtract 6 from both sides.
Then you divide
Divide by 3. That's the proper way. So those of you who have been kind of faking it and just guessing, you're going to have trouble here. But those of you who really pushed for it and said, okay, I understand the subtraction property of equality, I understand the division property of equality, it's going to be a cakewalk. Okay. So we're going to solve, here's an equation. 4x plus 2y equals 8. It's a linear equation in standard form. I want to solve it for y. So what does that mean? See my y here? When I'm all done, I want this equation to be written as y equals stuff. So let's find out how we do that. We do it just like we would do if numbers were there instead of variables. Isolate the y. Make y be all by itself. So let's start with our original equation. What I like to do, because it gets confusing, there's lots of variables, I underline what my goal is. My goal is to have y equals. This y is not going to move. Who's going to move? Everything else. So what moves first? To make this the easiest way. I mean, there's a couple of ways to approach it, but what moves first? This term? How do I get this whole term to be on the other side of the equal? Subtract it, yes. And then subtract. What's 4x minus 4x? 1, right? Do it to one side, do it to the other. So now he's gone. I'm getting a little bit closer to getting y by itself. Now, I always put the x term first. I would like you to get in that habit. You're going to find out soon why we always put the x term. You could write 8 minus 4x. I'm writing minus 4x plus 2. It means the same thing. Now, what do I do next to get y by itself? Divide by what? 2. You know what gets divided by 2? Everything gets divided by 2. Everything. Every term you have gets divided by 2, and y equals negative 2x plus 4. Right? So solving for y actually especially if I tell you to solve for y, it's the same as me asking you to put it in function form. So this is the function form of that original equation. Why does everything get divided by 2?
Always have the division property of
Why?
equality.
Right? Because you're supposed to. That's what dividing is. You're dividing this whole side is getting divided by 2. It's like distribution, because you can think of it as times a half, right? You're distributing that half. Everything. Don't just divide one term. Everything. Everything, everything, everything. I want to do another one just to make sure we're okay with this. 6x plus 3y equals 18. How do I solve this? Put it in function form. Right, because I want y by itself. 3y equals, now put the x term first. Be careful with signs. He's negative, he's negative, he's positive. Then what? Divide by 3. What gets divided by 3? Now you can do it like this too. Everything gets divided by 3. Everything. Now this is how you do it. You look this way. What's negative 6x over 3? Then you look that way. What's 18 over 3? 6. So either you can make one big line and remember to go this way, or you can make 2 lines, dividing each one separately. It means the same thing. And then, not always unit-wise, solve a linear equation. Ax plus b equals c. Solve for x. I underline where I'm headed. Right? So I remember not to move that one. Who's going to move first? The b. Subtract b. Ax equals c minus b. I want x by itself. Divide by x. So that's a big old one. And that's it. You're done. I don't have to worry about what is C. I don't know. Do I know what C, D, or A is? Nope. So I just leave it. Solving for a variable. How about putting, we did this one already. It's the same one we just did. How about this one? And I'm trying to find where I am, because hopefully you're following along. This is number 3. A equals half BH, solving for H. So this is the formula for area of a triangle. Well, let's say I know the area, I know the base, but I want to find the height. So let's solve it for height. Well, let's take it a piece at a time. How can I get that half to be gone? Multiply y by 2. I heard all various things here. Multiply by the reciprocal, because what's 2 times 1/2? 1. So it's like gone. But if I do it to one side, I do it to the other. And again, I like underline to remind myself, where am I going? I want h by itself, so what do I do here? Divide. Divide b. Does bh minus b help you? No. But b over b is 1. H equals 2a over b. Rewriting the formula for area of a triangle, in case I don't know height, but I know the other two, I can now figure it out. Let's try this guy here. A formula for converting Celsius to Fahrenheit. Yes. Can we give me 2 more minutes, okay? Give me 2 more minutes. Okay, so Celsius to Fahrenheit. So I'm solving for this. How do I turn a 5/9 into a 1? I can find an easier way. I can. There's an easier way than distribute it. Multiply by the reciprocal.